Welcome everyone to lesson 212. Today we're going to focus on what is the perimeter. Okay, and before I start talking about perimeter, I want to finish up with yesterday's lesson, problem 2-5, a learning log. What is a variable? Okay, a variable, go back to 2-5 right now to make sure that you have what is a variable. Okay, a variable, you should have this written down on your learning log, okay, because I need to make sure that we have this before we start today because it helps us out with perimeter. A variable is when we use a letter, that's a variable, right? A letter X, a letter Y, sometimes it's a different letter, okay? And we use this letter when we don't know the value of something. Right? We use a variable when the value is unknown. So you write, a variable is when we use a letter or symbol for an unknown number. Okay? And these variables come in all different shapes and sizes, right? Yesterday we had multiple variables. Yesterday we had the variable y squared and y. And today we're going to be doing something that is called combining like terms. Combining like terms has to do with looking at these two variables and asking ourselves, can I put this y squared and this y together? And the answer is no. Because see, these are different shapes. This is a y square. This is a y rectangle. They're not the same. I can't say I have two. I have one y square and I have one y rectangle. See, when we give this variable, we're also talking about its shape. And when we combine them, we are combining the number of shapes. And so that's yesterday where we finished up. Today what we're going to do is we're going to take this and look at perimeter. Perimeter is the way around. Now we're kind of doing two things here. We're talking about area, we're talking about perimeter, but in the reality of today's lesson, we are practicing combining like terms, dealing with variables and combining them. So here we go. I'm going to start off with labeling. You'll notice this is problem 2-11 in your notebook. And what we're going to do is we're going to write area y squared. Okay, how do I know that? Because yesterday we learned that the big square is a y square. We knew that because this is a y and this is a y. We practiced that yesterday. But today's goal is to talk about perimeter. The inside area is y squared, but today we're talking about perimeter. So here's what we do. We know that the long length top is y, so I know that the bottom length is y. If I know the side length is y, I know the other side length is y. And when we are combining like terms, we are looking at the variables and saying which one has the same letter and the same exponent. So I look all the way around. How many y's do I have? 1, 2, 3, 4 y's. So what I'm going to go ahead and do is write perimeter for y. Write that. I'm writing it on the inside of the shape. Okay. Let's do the y rectangle. Now I know that this y rectangle, the area is y. If the area is y, I need to think about the dimensions on the outside. Well, I know this long length was y, and I know this short length is 1. So if I know two of the sides, I know the opposites, y and 1. So let's go around and let's go ahead and add up the perimeter. The perimeter is, and I think, how many y's do I have? Well, I see the two long sides, so that's going to be 2 y's. And how many singles do I have? Well, I have the two short lengths, 1, 2. So here's the gist of what we're doing. Okay, we're going around the shape, we're labeling the dimensions, and then we're adding up. How many y's do you see? How many singles do you see? And you're going to do that for the x squared, the x, the xy, and the 1. I had students today ask me, Mr. McCoy, how do you know which one is which in the xy? Well, I know that x is kind of a short and squatty letter, so I know it's the short side. Y is a really tall letter, and that's what helps me remember it's the long side. Okay? That's something to help you remember. Okay? So, I want you to go ahead and find the area inside, perimeter outside. Pause the video and find the perimeters. All right, you should have your perimeters all done for the x squared, the x, the xy, and the single. Now, what we're going to do is we're going to continue practicing combining like terms by doing this mix and match problem. What we're going to do is we're just going to draw arrows to the correct variable. So I'm looking for another variable x. This has an x. Oh, but it also has a y. Let's see. Nope, 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 nope. Yep, it has an x down here. So I'm going to draw an arrow down to the number 7 because they both have an x. Matching variable, matching exponent. Okay? The number in front is called a coefficient. A coefficient, I can't spell, guys. Coefficient. In their coefficient. Man, I struggle to spell sometimes. You guys have trouble spelling sometimes? Coefficient is the number in front that tells you how many there are. So in 7's case, there are 5 x's. Imagine 5 blue rectangles. Okay, right? That's what that means. Imagine 3 blue rectangles. That's what it means when it says 3. There are 3 x's. Okay, but for right now, all we are doing is matching variables. So let's look at letter B. I'm looking for a y squared. Well, I see a y, xy. Oh, here's a y squared. Notice, combining like terms means same letter, same exponent. So all I need to do is draw the arrow. What I want you to do for the remaining problems is go ahead, go through, draw arrows to match variables. Same letter, same exponent. Pause the video now. All right, you should have those all matched up. Let's go ahead and dive into the meat of today's lesson. Today what we're going to do is to talk about the perimeter of complex shapes. This world is not full of simple shapes, simple rectangles, simple circles. They're filled with complex shapes. Oftentimes when we're dealing with perimeter, we're talking about fencing, we're talking about siding, going around a house. Have you ever noticed houses are never just like squares, like square or rectangle? No, they've got all these little, pop outs or these little edges that help give dimension and depth. They're always complex shapes. So what we're going to do is we're going to go around the shape and label perimeter. Here we go. X1, Y1, X1, X1, Y1, X1. If you need to pause the video to copy that down, please do that now. Okay, now that we have this written down in our math notebook, what I'm going to do is I'm going to pick a starting point. I'm going to start right here. Okay, and I'm going to count how many X's do I have, how many Y's do I have, and how many singles do I have. Okay, so I'm going to go around and count X's. 1, 2, 2, 3, 4. Okay, I've got 4 X's. How many Y's do I have? I have 1, 2. 2 Y's. How many singles? 1, 2, 3, 4, 5, 6. I personally mark stuff off when I'm counting to make sure that I counted it correctly. So my final answer here, the simplest form of perimeter that I have is 4 X's, 2 Y's, and 6. Okay? This is our goal today, is to go around, label the perimeters, and then let's add it up. Okay? Let's do letter B before I set it off on your own, because there's one extra thing that you got to focus on. Okay? Here we go. I've got a 1. I've got an X. I've got a 1, a 1, a 1, and a 1. But there's a complex side right here. Because, see, on this side, on the right-hand side of X, I notice that the whole thing is X. But the whole side is not showing. And so if the whole side is not showing, how much of it is hidden? Well, I know that this right here is hidden. And what is the measure of that hidden spot? Oh, that hidden spot is 1. So what I'm going to do is the whole thing minus what's hidden. The whole thing X minus 1 that's hidden. That's going to help me calculate the perimeter. How many X's and how many singles? Here I go. I've got 1, 2 X's. Singles, 1, 2, 3, 4, 5. Oh, did I forget something? Oh man, I've got this minus 1 that I didn't take into account. Now, this is not simplest form because I've got the positives and negatives. Here, in my wallet, guess what? I have $100 minus 99. Is that how we calculate money in our wallet? Do we say, I had $100 minus 99 that I spent. I have 1 left. No, we always calculate in simplest form. We say, okay, 2x, 5 the positive, minus 1 is 4. Simplest form. Notice different variables, because 4 doesn't have a variable. It's called a constant. So I've got 2x plus 4. So here's what I need you to do. I need you to look at C and D, go around the horn, okay? If you need a hint, there's a whole X minus what's showing. A whole Y minus the X not showing. There's the hint if you want to write that down. So your job is to do C and D, pause the video, find the perimeters now. All right, last problem. Now this is going to give you a hint as to checking your answers for the previous problem. Now what I've done is I've taken the simplified expressions and I have left out all the X's and all the Y's. Whoop, 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 whoop. Because we're going to evaluate the expressions and find the value. So let's go ahead and get those X's and Y's out of there. And what we're going to do is we are going to evaluate by taking the value of X, and we're going to take the value of Y, and we're going to find the value. Because this is the point of using a variable. Variables can change. So let's suppose that X is 3. 4 times 3 is 12. Okay? 2 times 8 is 6. Is plus 16. And 6 the constant. And I am left with a value of 28 plus 6 is 34. If X were 3 and Y were 8, the value of the perimeter of shape A would be 34 units. Okay? This is actually calculating the perimeter. So here's what I want you to do. I want you to take B, C, and D, and I want you to take the variable's value, plug it in, and simplify to get a simplified answer. Now this is going to conclude our lesson for 212. thank you for grabbing your math notebook from the office if you are absent and following along every day to make sure that you are getting the math instruction to stay caught up. Thanks, guys, for your work, and I'll see you tomorrow.